this is the third part of the series that I want to make, and yes, of course, I recorded them right behind each other, but I divided them over a couple of videos to make it one story, one complete story. Okay, again, I wrote a paper about the mathematical probability compared to physical reality. Is that the same thing? And as you already guessed, and you read between the lines, then you could have concluded already that no, it's not necessarily the same thing. Okay, we move on to that, and I'm going to the board again. I'm not to bore you, but that's the way it is. Let me see where did I stay? Okay. I used in one of in first video the standard deviations S, 1, S2, S3, S, and so on, so on, so on. Well, I use that table a little bit here again, and okay, we're going to show to you some more, and I'll shift the board again closer to you so you can see it. No, this side. Okay. Yeah, here it is. Yeah. Okay. Now, 1S represented a chance. For example, in all heads up, or if you use coins, all heads up or all heads down, or tails up, a chance of 1 in 6.3. Yeah, so all heads up has a chance in 1 in 6.3, and all heads down, etc. Well, these are the chances in the extreme parts of the Gaussian graph. It's 1 in 6.3, 1 in 43.9, and so on, so on. So I showed you these numbers. Well, if you take the logarithm of these numbers and you plot it out in a graph, you can get this up to 8s, because 9s in Excel, I did everything in Excel, which has a limited amount of digits that you can use before your computer says, hey, you figured it out yourself. Now, so I went to up to 8s or 8 or 9s. Well, but the rest you can model. And now it turns out, suppose that you want to go to 1,000 coins, heads up or tails up. We saw already that's about 1 in 10 to the power of 301.03 something, a chance that all heads are ending up or all tails are ending up. That's the chance. 1 chance in 10 to the power of 300 something. Okay. But now, my computer stops at S3, S8S, and from that on you have to model things. Yeah. Well, this is the logarithm of these chances, 1 in so many chance, and it's the logarithm curve of it. It looks a little bit like this. And from that point on, you have to model it. So I modeled it in several polynomials and so on. And this is what I found, is that if you want to calculate the chance of 1,000 coins all heads up or all heads down, it turns out to be laying somewhere in the 20 to 50 S range. So if you take this graph here, if you prolong this graph, 1S, 2S, 3S, and so on, you end up somewhere in the range of 20 to 50 S. Now, in the science community, 5 or even 6S is taken as the limit from, hey guys, everything what's beyond is considered as being noise. So I put it here on the other board. So scientifically spoken, where's my pen again? Well, it doesn't matter. Well, scientifically spoken, the 5S to 7S limit is the acceptable maximum limit. Above that, scientists all over the world are saying, okay, everything which is beyond 5S or 7S at the max is discarded, is being considered as being an outlier. It's not scientific representable for this measurement any longer. We want to measure something, okay, fine, and then you put it on the graphs and you say, okay, here's the limit. Everything outside of 5s or up to 7s at the max is discarded, is taken out of the data as not being seriously scientifically correct. Okay. So that means that 20s to 50s has scientifically spoken by the whole world community has scientifically no physical meaning anymore. Yeah? It has no meaning. That means that tossing 1,000 coins all heads up or tails up has a statistical chance of 10 to the minus 31, or other speaking, 1 in 10 to the power of 301.3003. Yeah, one chance in that number, which is very small. Yeah, this is mathematically, it's correct. I can have no argue against the mathematical correctness of it. Yes, but this lays estimated in the 20s to 50s area. That means that the whole scientific community, which has a limit to 5 up to 7s, actually tells, well, okay, there is the scientifically correct limit, and 20 to 50s is far, very far outside of that limit. So it has no scientific physical meaning anymore to it. It lost its physical meaning. That means that the conclusion is that this is not part of physical reality. And that's the point that I actually try to make, that some probabilities are mathematically correct, but they have lost their physical meaning because they're beyond the limits of which is scientifically acceptable. And basically that's the conclusion what I try to convey across to you. Okay, so that's the point from this video, and thanks for watching again, and see you in the next video, because it has big